Our three log properties can also be used to condense an expression. What I mean by condense is go from two or more logs in an expression backward to having a single log. So basically, if we had two logs that were subtracted, we could take that back to a single log of the quotient of the original inputs, or if they're added, back to a product of the inputs. In terms of condensing, we can also think about bringing an exponent, something that is multiplied by the log, up into the log as an exponent. So condensing actually uses the properties backward. And it can be really valuable when we solve equations. So let's look at a couple of examples. If we use the log properties here to condense this expression, 2 log of x minus 3 log of y plus log of z. The very first thing you want to take care of when you're doing this is any exponents there happen to be. So notice there's a 2 out front of this log and there's a 3 in front of the second log. Both of those can be written as exponents to the appropriate input. So when we rewrite this, instead of 2 times log of x, this would be log of x squared. The second one we'd have minus still, but log of y cubed, and then plus log of z. There was no coefficient out front of the last log term, so we don't need to pull any exponents up. The next step is just to simply work from left to right with any subtraction and addition you have. So here we have subtraction. So if we work through that subtraction with the subtraction property from up above here, this middle property, what that's saying is that when we have two logs subtracted, what's really happening if we want to write it as a single log is we're using the x squared and the y cubed as a fraction in the new input. So we end up with x squared over y cubed, or x squared divided by y cubed. So the subtraction rule takes the inputs and divides them. Notice it creates a single log. It doesn't divide the logs, it just divides the inputs. Then we still have that y log of z rather at the very end. Now our next rule to work with is the addition rule, which means that we're going to multiply the inputs. Now we already have a fraction, so when you multiply inputs, think about how this z is over 1 when you go to multiply. When you multiply fractions together, you're always multiplying numerators, so that z is in the numerator and the x squared is in the numerator. So it's going to be x squared z all over y cubed times 1 is just y cubed. So notice we went from 3 logs to a single log. So that's why it's called condensing. The other thing I want to point out here is that you can predict where your inputs are going to end up being if you look at the sign in front of the log. So the sign in front of this first log was a positive. So our x, which was the input of that log, is in the top of our final result. The next log had a minus. This log being a negative means the y it should end up in the denominator, and that's where it is in the end. And then a positive means that the input of this final log term, the z, should end up in the numerator. So that's kind of a little hint to check your work. Look at the signs of the original log terms and then look at your fraction in the final single log and your answer. Here's another example of condensing a log expression. Once again, in condensing, the idea is to go from 3 logs, which we have right here, and ideally get down to 1. So always start with your exponents first. If you have a number outside of a log, you're going to pull that up as an exponent of the input. So we're going to pull that 4 up as an exponent, and then we've got one other coefficient out front, the 1/3, that is going to go into the exponent of z. All right, next, let's take the expressions from left to right again, starting with the subtraction on the left. Subtracting means we are going to divide the input. So we're going to have the natural log of x to the 4th over y. And then we still have this last log term. Again, it is subtracted. So to do the subtraction, we're going to again think about dividing these inputs. Now when you divide with fractions, remember what's going to happen, a little reminder, is that when you divide fractions, you flip and multiply the second. So y to the fourth, x to the fourth rather, over y times, do the reciprocal of this, 1 over z to the 1/3. So that z ends up in the denominator. So in our final answer, we get natural log of x to the fourth over y z to the 1/3. Now another way to write that 1/3 is that it could be written as a root. So you could say the natural log of x to the fourth over y cube root of z. One last check. Remember how I said in the last example that the sign in front of the log tells you kind of where that input's going to be in your final fraction that is in the input. So this is a positive term, so the x should end up in the numerator, and it is. A negative term means the y should end up in the denominator, and that's where it is in the final answer. And another negative term means the z should end up in the denominator, and sure enough it is.